Okay, welcome back, welcome back. Some interesting things I thought I'd record. Okay, part of me want to do that thing, but it's pretty exciting, okay? That's me excited. Okay. So I finished this. I was watching it, which I brought up in this episode, the epicenter, where I'm trying to figure out what's going on along this boundary over here. Here, where recently in the Earth expansion process, mind you, where it was kind of like this, or it was like this too. This side of Australia had these islands specifically. This side of Australia, though, had these islands with Papua New Guinea atop it. Not quite this scale, admittedly. And there was a current flowing here, and a third current flowing up here that made this region have, especially an ammonite spiral vortex occur structure that is in the magnetic anomaly map here above Australia, where the nucleus of the ammonites, like remaining body, is generally center on the crust underneath the continental crust of Australia, where like the body extends outward. Okay, so there's that going on. Here's the current coming in here. Current coming in this way under North America. And then a third current that is coming through here, across from here. But generally where this is hard to see because it's all scattered in the data now, is more like this. So there's another current that's coming down this way. The little current that could, I talk about it, and the focus beam are two of the episodes I can recall talking specifically about this. Whether or not the precise details are exact yet, I don't know. I'm still working through it. But some major progress is going on right now. This Baja BC is just major progress is going on right now. Major progress. Okay. So let's go through that. So the Rangelia, I'm not sure how to say it. This region that's generally here, and I think also up here maybe? I don't know. Generally, though, a region here that was created by physically just being brought to it, it seems. Okay, so I was watching this episode here, and a couple things popped in my mind. Rangelia, this region, formed 230 to 225 million years. And I was like, and then on top of that, that's just when it formed. When it was docked is 100 million years. So what's a running theme in this interpretation Baja BC, which is valid, so it's picking up on things that are happened, is 100 million years to 85 million years radiometric dating, mind you, because that's not actually what the time was, but besides the point, in that actual radiometric dating time, that's when the things were happening. And the West Idaho suture zone, maybe something of that nature, turned off at 85 million years, which ended up like stopping the feed to the region, I guess. Which is this region. So I guess there's a current flowing up above this the below current here at a time I'm going to talk about, I guess, that is going up this way, but is capped off, and so it can't go up that way at some point. And so there's things going on down here afterwards. I don't know. I don't know. That's just based on something that they said. Okay, but the point is, I don't want to get too distracted. The point is, 100 million to 85 million is very important with a lot of things. A lot of things are going on then. Like the Caribbeans are being formed, this region. And so according to plate tectonics, there's an ocean here. But according to expanding Earth, there's not an ocean there. There's Australia, according to my interpretation at this point, because apparently within the expanding Earth community, people don't believe Papua New Guinea to have been where I'm placing it, but that's where it was because of reasons I've discussed in depth. So, besides the little debate within the expanding Earth community that doesn't really get to see the light of day, besides that, this is where it was on the expanding Earth. And so that means that, like, this region that is in question, the Galapagos hotspot region, which is probably generally forming in this region, it is very proximal to Australia. So I was like, you know what? When did there's a row of super volcanoes over here. When did those happen? Let's see. Answers blowing in the wind. Oh my god. When did Australia super volcanoes erupt? So there's this one. 256 to 252. So that goes back to the Rangelia, 230 to 225 million. So it's kind of somewhat in that region. So there's that. And then there's... Where is it? I found 100 million. When I searched for this, I found 100. Let's look. Australia super volcano 100 MA. Let's see what's up. Maybe this will help. I got a list. I don't feel like reading this. It's hard to text search for a year. Like maybe if I just search for 100. A lot of times, that's like actually specific enough. Like there. Okay. What are their ages? Four older than 50, 3 older than 100. Altered asphalt tuff deposits in the eastern United States and Europe, all about. This is not Eastern Australia supervolcanoes. Let's do, there it is, there it is. 100. Were once lined with volcanoes. That was another paper. Okay. When New Zealand began tearing away from Australia's eastern edge. Boom, baby. Earth expanded. This right here is related for sure to this right here, which is related to this current that was flowing underneath North America and running into the other currents. This one, which was going generally up this way. And I believe it even continues across here as that. And then this current coming down here. So then apparently got another, like when this, like literally like novas, it seems pretty much. It puts ophiolites over here that are sponge-like is how he described it in this video. Let's see if I can find it. No. In this paper. So apparently it has a ridge this way and a ridge this way, and what is going on here? It's like the current started to fill this way, and just initially this current was more across and just filling in down here, and then just slowly moving down this way and creating some of the like the Laurentia shape underneath it, support structure, but like in a sequential way that led to something of that nature that I was just looking at wherever that went. This across, and then around 100 million years, the current reaches this like position where it's actually able to sever between North America and Africa, I guess. And it really flows out this way. Oh my god. I'm assuming that's what's going on here, is just like a trend based on dates of things. Hotspot, Great Meteor Hotspot Track. This paper looks really, and then ophiolites here. So like ocean rocks that were like scattered in this explosion. Pretty much this system here that was really under here, like on the Galapagos hotspot, had a over layer that was cooling, relatively speaking, that took this shape still, and so it like when the system like nova'd, it pretty much just shed the over layer like a lizard or snake for like shedding its skin and it opens wide, and the skin's over here. But there's this whole new ocean floor that's formed. Okay, so let's see. Australia, eastern supervolcanoes included 100 million years. 256 to 252 million for like some supervolcanoes in Australia. I didn't try to find them exactly. It's probably useful to know where these ones they're in Australia. But interestingly, so there's so mind you, there's first of all, there's supervolcanoes 100 million years. And then 100 million years is when all the Baja BC stuff's going down. And then there are supervolcanoes 256 million years in Australia. And that's when the Siberian traps are going off up here. And notably, the difference is the Siberian traps were described as relatively passive events compared to the catastrophic events of the supervolcanoes, where there's just like they're not quite the same thing occurring. Where over here it was explosive, and what makes a volcano explosive is that it is composed of like more like sharp brachiated, I don't know the word, like there's types of lava more towards something like this that produces like a resistance to the flow. Resistance to flow because there's big blocks in the way, so that when they move, they get just boom exploded off, and behind them flows this pressure of current that was building, or a more laminar fluid flowing, just passive flood basalt type of flow, explosive flood basalt type, relatively speaking. Also, water can form large rounded blobs when lava erupts underwater. I haven't really thought about incorporating pillow lava into my interpretations very much whatsoever. It's probably important in ways that I should at least keep it in mind for the time being, and maybe something will pop up as I go. That's how it seems to happen. I have seen recently lava bubbles. I don't know where. But yeah, so the Siberian traps, my thought is this current, essentially what's going on is the mantle was punctured by a vortex. I know. Space was inwelled into the earth, and it upwelled mantle that flowed underneath the crust at the crust mantle boundary. And basically, as it flowed, it began to solidify mounds where like boundaries of the currents were, that produced like support structures underneath the crust. And it just continued to flow and flow as the earth rotated. So one direction it went this way, like in the direction encouraged by the rotation of the Earth going this way, and then a focus channel beam went the opposite direction, and the beam, or the fanning out one though, ran into water where it began to solidify, whereas the focused one did not. So it went up here, went up here, went up here, went up through here, and as it's going, it's not producing a significant support structure. It's more so just flowing, like this, just flowing though, and not producing mounds, because it hasn't yet interacted with water enough to solidify. Then it comes around here where it does kind of begin to, and maybe that even leads into like some degree of explosivity into its capacity and travel, because it essentially runs into over in northern Asia, in Russia, in the Siberian traps, comes in presumably against pressure that generally was flowing up this way, but it wasn't nearly as much as the current generally this way, so it just got overwhelmed back this way, producing new boundaries, but initially a boundary generally up there. And so it flowed across, and when it did that, it began to like flow into the Siberian traps, but it doesn't seem to have exploded the same way, essentially. So there's the focus beam current producing the Siberian traps simultaneous to the fanning out current that then runs into water, because it fanned out probably, so it's more likely to run into water also. And maybe that's even related to like endothermic, exothermic reactions. I don't know which one runs into water first and solidifies, of the focus beam or the fanning out beam. That would be cool. But anyway, the fanning out beam begins to solidify here, through here, but then Australia was over here, basically like here, relatively speaking. And so this current just kept going into Australia with the explosive material of the fanned out current that ran into water and became more explosive. So that supervolcanoes actually were present in Australia, which probably is why it's red, like all of the supernovas basically that are occurring, where like it's painting the region in red. And even over here, like it's right by, so it has effects on the proximal region. And over here, this is down here, so like the current's coming in this way and this way, causing current to go this way, and basically sawing upward until it physically opens between the continents, and then the current's able to like push outward then and open it so it opens it not from here, but as the like current builds past the opening, it's able to open it more. And then once it opens it enough, it physically just like, it opens it to here, basically. Here first, and then moves more out here, and then out here, relative to this Solomon Islands segment pointing in here. Let me just read some things I wrote down. Let's see. San Juan Islands, or island, 100 to 85 million years. Rockies reach an age of 100 million years, so this is really important. One of the major aspects of Baja BC and why it's not acknowledged within the geological community is like the like predominant interpretation of how the region formed is because of its impact on the interpretation of the Rockies and how they formed, because it basically shows they're related and they can't be related to maintain the interpretation of the Rockies. So it really starts to extend into these other areas and realms of study and interpretation that have much more defense. Like they're not just gonna easily keel over and be like, oh yeah, the Rockies, or we got that wrong. It's so central. It's like so important. It's the Rockies. We can't admit, like, of all the things to admit, it can't be the Rockies. Maybe if it was just Rangelia, people would be like, all right, fine, I moved from down here, or wherever exactly. It moved from in this general region up here. Fine, 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 fine. We acknowledge the data. Fine, fine. We acknowledge the data. Really, that's all it is. uh, but so, but then the Rockies. I mean, the Rockies are formed a different way, and that can't be so. So, nope. That's the real issue. Is it's too impactful that it's hard to have the dominant voices be overpowered by reason. It's just hard to overpower dominant voices with reason because they don't have to listen to reason. Okay, myself included, admittedly. Okay, with that in mind, 100 million years, all the arcs are getting smashed into Idaho and south thereof. So there's some things going on down here in the area of 100 million years. Like I believe they're leaving behind chunks, so there's evidence that the Rangelia was, or some region left behind chunks in Nevada. I wrote it down. Where is it? Part of Intermontane is found in Idaho and Nevada. Okay. Intermontane. This is why I really even hit record. I was starting to look at that. Where is it? There it is. Intermontane belts. Here, right? Okay. Sorry, we're gonna go back and forth a bit. Okay. That'll do. So just for general reference, the boundary here is pretty good. So it generally, at least seemingly, I don't know why it starts at exactly the boundary of the United States. That doesn't seem to make sense. I guess it would help if you guys could see. Okay. So for some reason they don't show it there at least, but maybe it extends a little bit. Although it's possible that the boundary is chosen based on some natural divide in the land where maybe it was there. I don't know. Let's just say that maybe it extends a little further, but maybe it generally stops in that area. Okay. So here's the insular belts, coastline. Apparently, I think this is Rangelia, coast belts, intermontane belts, Ominica belt, foreland belt. Okay. Point is, there's some accreted like sequentially from here, here, but like different units that get shoved up here, one after another, but not simultaneous, so that they're different units, I guess. Something about them makes them fundamentally different units in terms of like a Baja BC interpretation. I think they may even be sourced from different locations, like paleomagnetically. But, okay. Nevada, Idaho. Some of this has been found and left behind in its movements in Nevada and Idaho. So let's look here. This boundary generally is here. So if we go over this way, seemingly it's hard. I don't want to like take the time to pinpoint exactly. It looks like here, up here, going through here. It looks like I'm trying to find the boundary of it, intermontane. Like generally it looks like it's here, down this way. Like in terms of just not by like looking at this map, but by just positioning it off from this map. I'm just trying to put it there in my head because it's not that like, I guess I could just take this out of there. Because I saw something, I was like, oh, okay. Yeah. So pretty much I'm following this line. And I noticed it's got kind of like a track that maybe here, like generally in this region that generally has this shape. But then stops around here. Around here. But then there's parts of it back in Idaho, was it? Idaho and Nevada. So here's why, let's see. Idaho is all the way over here. Trying to, oops. I just hate labels so much that when I put them on, isn't it ironic? Don't you think? It's like rain, what a dumbass I am. I know I'm short-sighted. Don't really think this is probably Idaho. Generally here. Who would have thought? Okay, so Idaho here. So there's pieces of it maybe out to here. I'm not sure if I'm precisely, like maybe Idaho's more here. I really don't want to try to, fine. It's at least good. 117, 43. Yeah. Okay, so around here. This is probably around here then. Here. this generally here. I'm not sure where it's found in Idaho. But I was thinking that maybe there's tracks, like maybe it followed the here, when actually through here, and like here, like specifically there, up specifically there, and then up through here, basically, through here, and then kind of atop the current going the other way, so it's kind of slowing its motion down. Because if that's the case, then like it would irrefutably be sourced from generally down here. Like if we could find a trail, mind you, that's not the only one. Like over here, that like in a like manner along this way between here. If we follow this, where there's kind of like a trail here. Like there's still a trail here, it looks like, that kind of hugs, like pushes into a boundary generally here. Up this way. Up this way, and then maybe slides in here, like that. Maybe then, Hawaii. Hits the armpit. Because really, like, even though it's going on, even though it's going on over here. Wait, is it going? It must be going on above this. This is the boundary. It's bounded by over here. So, like, where Hawaii seamount starts is maybe it's generally related to this region before the ocean, like, point at the same location, not at the same location. So, like, before the ocean opened and took this point, which was where the Hawaii rolled from over here though. Like moved it all the way over. Maybe. Not sure how that makes sense, but just spitballing that aspect at least. Okay, next thing I wrote down, this Galapagos hotspot, 2 plumes, second to Caribbean. I think I already mentioned that. That just really supports, essentially this is like a nova event, like a particle boom, maybe. So maybe the particle. No, no, I don't know. I don't know. I was gonna say maybe Hawaii was bigger than I realized. Like it had even more outer shells, and they were like getting. I don't know. Maybe it did when it rolled out from underneath Australia. It rolled in to this region. Maybe it like created like a ring around it, like an actual galactic disk of like material of like rotating continental crust segments that then the current swept away, and then it swept away with the current, and it also moved up with the current. It's funny now that I think about it. I was having the same issue that plate tectonics has, where people are like, it's couldn't have moved that far. There's no way that that location up in Canada moved from down in Mexico. It doesn't make any sense. It's just no way. I had that same issue. I was like, there's no way Hawaii, as much as I would like it, there's no way Hawaii formed as a sphere underneath Australia and rolled out of this segment and made its way all the way to somehow disappear rolling down here. But you know what? This Baja BC thing opens some doors. Oh, there's a way, all right. I see it now. I see it now. Okay. So that's my updates. I'll cut this off nice and sweet, relatively short. Short and sweet. Whatever. Compared to my like typical. I guess I'm keeping them at an hour-ish. Alright, peace out.